We had problems yesterday dealing with factoring three-termers. Are there any there you'd like to see worked? Any that you had trouble with? Any you want worked out on the board? Yes.
51.
51? Okay, 51. What we have there is 3x to the fourth plus 7x squared plus 2. We have a three-termer. 3x to the fourth plus 7x squared plus 2. Now, there is nothing common to all three terms that we can extract. Therefore, if it's factorable into two quantities. We put in what we know for sure we're going to have in these parentheses. Tony, what do you know for sure you're going to have in each of these parentheses?
X squares. And
sure, x squares. Both are x squares. What else do you know for sure?
Positives.
Positive. Now, in this problem, it was pretty easy. And the reason it's pretty easy, there's only one way you can factor 3. And that's 3 and 1. There's also only one way you can factor 2. 1 times 2. So you can put the 1 here, the 2 there, and check it. If that doesn't work, you alternate the 2 and the 1, see if that works. Well, let's see what happens. If we multiply the outside, we have 6x squared. The inners, we have 1x squared. If we add those up, we got it, Tony. Okay? Any others? No others? Okay. Well, let's go on. Today we're going to start working with fractions. Fractions. Everyone knows what a fraction is. It consists of a top part called the numerator, bottom part called denominator. Today we're going to do some operations dealing with fractions. The first operation we're going to work with fractions is simplifying a fraction, simplifying. Now you often refer to this as reducing, but reduce means you lose something. You're not losing anything. Simplifying a fraction. So let's take a look at an arithmetic problem. And let's see what happens in an arithmetic problem. Then you'll understand what happens in any algebra problem, because algebra is just an extension of arithmetic. 6/15. I like to simplify this fraction. 6/15. What is it?
3/5.
3/5?
Yeah.
I didn't get 3/5.
Oh, 2.
2/5. 2/5. Question is, how do you get it? You see, now, if you understand what's happening in arithmetic, algebra is very simple. It's the same game. How do you how'd you get this 2/5? Yes, Jan? You find a common, what?
Forget the name. Number.
Common number. How do you find this common number?
See what multiplies into 6 and then...
Yeah, she said, see what multiplies. Better word. Factor it. Sure. We factor. 6, the prime factors of 6 are 2 and 3. The prime factors of 15 are 5 and 3. But we know that anything divided by itself is 1. So we have 3 divided by 3. That's 1. So what do we come up with? 2/5. You see, we didn't have to look for anything. It found us. The most common explanation I get of how you simplify a fraction, students say you find out what goes into both of them. You don't find that. Here it is right here. It tells you what goes into both of them. You break it into prime factors. That's what you do arithmetically. Let's see if you can transfer that thinking to an algebra problem. Let's suppose we have x squared minus 7x plus 12 divided by x squared plus x minus 20. There we have an algebraic fraction. That's x squared minus 7x plus 12 divided by x squared plus x minus 20. And I like to see if you can simplify that fraction. Okay, Beeb, do you answer?
X minus 3 over x plus 5.
Yes. Yes. The answer is x minus 3 over x plus 5. How do we get it? The same way we did in this arithmetic problem. Exactly the same way. We factor both numerator and denominator into prime factors. If we factor the numerator, we come out with x minus 4 quantity x minus 3. Denominator, if we factor that correctly, we come out with x plus 5, x minus 4. Now what we're going to do is look for identical factors in numerator and denominator, because anything divided by itself will be 1. Notice the x minus 4 and the x minus 4 is 1. So our answer is x minus 3 over x plus 5. Okay? I'd like to give you another problem. Let's take a look at this one. Nice, easy one. I think, let's suppose we have a squared minus b squared over a squared minus ab. Okay, for some reason, this particular problem gives lots of students troubles. You shouldn't. The name of the game is factoring. In order to see if this is simplified, we have to have it in factor form. So we take a look at our numerator. A squared minus b squared. It's a two-termer. In factoring a two-termer, our first question is there something common to both terms that we can extract? And the answer is no. Second question, are both terms perfect squares separated by a negative? And the answer is yes. Therefore, it's factorable. We factor into a plus b, quantity a minus b. And there's the numerator factor. Denominator. Again, it's a two-termer. First question, is there something common to both terms that we can take out? The answer is yes. We can extract an a. We extract an a, we have a times a quantity, a minus b. Now that we have, in factor form, we look for identical factors in numerator and denominator, because anything divided by itself is 1. This is a 1. Notice, we get an answer of a plus b over a. We cannot cross out these a's, because that's a term. Only factors. Remember that. That's important. Okay? Now, one more problem. Let's make it just a little bit harder. Let's suppose we have 6x squared minus 11x minus 10 over 15x squared plus 4x minus 4. Okay, as I emphasized before, the name of the game is factoring. If you know factoring, the section on fractions is going to be a very easy section. Very easy. The game is factoring. We want to see if we can simplify this fraction. Well, the only way we can tell that is to have it in factor form. So we factor the numerator. If we factor the numerator, we have x and x. Signs are going to be different. Now the factors of 6 are 1 and 6, 3 and 2. So try the 3 and 2 first. Factors of 10. Factors of 10 are 1 and 10, 2 and 5. If I use the 2 and 5, I must put the, what here? 2. I can't put the 2 there. I must put the 2 there and the 5 there. Check the middle term. Hey, it works. Denominator. 3 terms. We have an x and an x. Signs are going to be different. Factors of 15 are 1 and 15, 5 and 3. Factors of 4 are 1 and 4, 2 and 2. Does that work? Yeah, that works. And there's both numerator and denominator in factor form. We now look for identical factors in numerator and denominator. Well, there they are. Our final answer is 2x minus 5 all over 5x minus 2. Okay? Nice, simple. You know how to factor. This is very nice and easy. Now, let's suppose I have an expression and I like to simplify it. So I factor my numerator and I come out with x plus 3, x minus 2. My denominator I factor and I come out with 5 minus x and 3 plus x. Those are the factors of my numerator and denominator. So now I like to see if we can simplify this. Are there identical factors in numerator and denominator? Jan, you see identical factors in numerator and denominator? No? Tony?
Mm-hmm.
What?
3 plus x and x plus 3.
Yeah, they're the same. X plus 3 and 3 plus x are the same. Addition is commutative. That means no matter which order you have them, it gives you the same answer. 3 plus 5 and 5 plus 3 are exactly the same. Likewise, x plus 3 and 3 plus x are the same. Okay? So they go up, and our answer is x minus 2 over 5 minus x. Take a look at another problem. Let's suppose I factor my numerator, and I come out with x minus 3, x plus 4. I factor my denominator, and I come out with 3 minus x, 7 plus x. So this is what I get once I factor a numerator and a denominator. Now I want to see if we can simplify this. So what I want to know, are there identical factors? No. No. You see, subtraction is not commutative. X minus 3 and 3 minus x are not the same. But the question is, can we make them the same? Well, let's see. We had an exercise where we had a parenthesis and we factor out a negative 1. If I factor out a negative 1, what's going to go inside the parenthesis? 3 minus x. Everybody see that? If I factor out a negative 1, that means I divide each of these by negative 1. I get negative x plus 3, or 3 minus x. And I try to emphasize that when we had this section. Anytime you have two terms separated by a negative, if you factor out a negative 1, all you do is reverse those terms. Anytime you have two terms separated by a negative, if you factor out a negative 1, you just reverse the terms. So I factor out a negative 1. Now do we have two? Yes, we do. So this is what we have left for an answer. Now, When I talk about a fraction, I talk about a positive fraction or a negative fraction. There's a time fraction. I don't talk about the numerator being positive or negative, denominator being positive or negative. What is the fraction? That's what I'm interested in. Well, here our fraction is going to be negative. So our answer would be negative quantity x plus 4 over 7 plus x. Now I like to emphasize this, try to reinforce what we just showed you. Let's suppose we have a numerator, we factor it, and this is what we get. We have a denominator, we factor it, this is what we get. Now what I like to do is I like to simplify. Well, let's go back to this problem right here. Notice what we did. We reversed the terms of a factor. And when we reversed the terms, what effect did that have upon our fraction? When okay. We don't say it becomes a negative, we say it's negated. What does the word negate mean? Yeah, to change the sign, okay? So anytime we have two terms separated by a negative and we reverse their order, we negate the fraction. Aren't that? Let me show you what we mean now. There's nothing that we can extract here. I mean, nothing that will divide. So what our job is to see if we can make anything divide out. Well, I have an x minus 3, a 3 minus x. I'm allowed to reverse this order. I'm allowed to make that 3 minus x. As long as I do what? Make the fraction negative. Notice what happens. 3 minus x is now a 1. Well, look, again, I have an x minus 5. I have a 5 minus x. Well, I can reverse their order. Anytime I have two terms separated by a negative, I can reverse their order as long as I change the sign. So now this becomes positive. X minus 5. No. Here again, I have an 8 minus x and an x minus 8. I can reverse one of them. It doesn't make any difference which one. Just one, though. I'm allowed to reverse the terms as long as I negate the fraction, change the sign. So they go out. And our answer turns out to be negative 1. That's the answer. So anytime you have two terms separated by a negative, you can reverse their order as long as you negate the fraction. And we showed you why. Okay? Any questions? Okay, let's go on. We know how to simplify fractions. What we're going to talk about now is multiplication of fractions. So I'd like to give you a little definition. A over B times C over D is equal to A times C over B times D. What we're saying here is that any time you multiply two fractions, all you do is you multiply the numerators, multiply the denominators. So let's take a look at our arithmetic problem. Let's suppose we have 3/7 times 2/5. Arithmetic. 3/7 times 2/5. What do we get for an answer here? Roy?
6/35.
6/35. That's correct. Because by our definition, this is equal to 3 times 2 over 7 times 5. Which is, Roy says, is 6/35. That's what you do in arithmetic. I'd now like to show you an algebra problem dealing with multiplication of fractions. X squared minus 2x minus 24. divided by x squared minus x minus 30 times x squared plus 7x plus 10 over x squared plus 5x plus 4. Okay? Just copy the problem down and stop. Just copy the problem down. That's x squared minus 2x minus 24 over x squared minus x minus 30 times x squared plus 7x plus 10 over x squared plus 5x plus 4. Just copy the problem down and stop. Okay. Okay. Now it says multiply these two fractions. Multiply these two fractions. Now, of all the things you have ever learned in math, of all the things you will ever learn in math, there is nothing easier than multiplying algebraic fractions. Nothing. Watch. I'm done multiplying. Done! That's what it says to do. A times C, B times D. What are we going to have to do now? Factor. Why are we going to factor? Yeah, to see if it's... Right, see if we can simplify it. See if you can reduce it. We have to factor it. So again, we factor. If I factor my numerator going across, I have x minus 6, x plus 4, x plus 5, x plus 2. And there's the numerator factored all the way across. If we factor the denominator, we have x plus 5, x minus 6, we have x plus 1, x plus 4. So there is both numerator and denominator in factored form. Numerator, denominator is in factor form. Question. Are there any ones in this problem? Remember what a 1 is. 1 is something divided by itself. Are there ones in this problem? Roy?
Yeah.
How many ones do you see?
3.
3 ones, sure. 3 ones. X minus 6 divided by x minus 6 is a 1. X plus 5 divided by x plus 5 is a 1. X plus 4 divided by x plus 4 is another 1. All we have left is x plus 2 over x plus 1. And that's the final answer. So you see, multiplication of algebraic fractions, very, very, very trivial. This is it. Once you multiply, you have to factor to see if it simplifies. Always. Anytime you have a fraction that can be simplified, it must be simplified. So in order to find that out, we factor. Once we get it in factor form, we look for ones. A 1 is anything divided by itself. Okay, let's try one of those. Suppose we have 3x squared minus 7x minus 6 over 2x squared minus x minus 1 times 2x squared minus 9x minus 5 over 3x squared minus 13x minus 10. Yeah, minus 13x minus 10. Okay. What we have here is multiplication of two algebraic fractions.